Hey, I'm Brian, and this is Ship It Weekly by Tellers Tech. Quick heads up before we get into it, my voice is a little rough this week. I've been fighting a cold, so if I sound like I've been yelling at Kubernetes for 3 days straight, that's why. All right, here's what we're talking about this episode. First, IBM is buying Confluent. That's right after the HashiCorp deal. So we'll talk about what that means if you're on Confluent Cloud, running Kafka on-prem, or trying to pick between Confluent, MSK, and do it yourself. Second, there's a nasty React vulnerability people are calling React2Shell. It's a 10.0 RCE. It's been exploited in the wild. And if you run platforms for front end teams, this absolutely involves you, even if you've never touched React. Third, Netflix wrote up how they consolidated a big chunk of relational databases onto Aurora Postgres. They saw up to a 75% better performance and solid cost savings, and they simplified their fleet. We'll talk about what's real there and what's marketing. In the lightning round, we'll hit OpenTofu 1.11, some Terraform tips from the trenches, Ghosty going nonprofit, and a pair of tools around spec-driven development with AI. And we'll wrap with a human story from your brain on incidents about what big incidents actually do to people and how to make that less awful. Let's start with the big acquisition, IBM and Confluent. So IBM is buying Confluent for a very large pile of money. They already grabbed HashiCorp earlier, and now they're adding Confluent, which is basically Kafka as a product, with managed clusters, connectors, governance, all the stuff around the core broker. If you zoom out, this looks pretty intentional. HashiCorp gives them a control plane story, Terraform, Vault, Console, all of the infrastructure lifecycle pieces. Confluent gives them a data plane story, real time streams, feeding analytics, and AI systems. From IBM's point of view, that's great. From your point of view, this should trigger some questions. If you're a Confluent Cloud customer today, I'd be asking, what's the realistic time window where pricing and packaging stay roughly the same? 12 months, 24 months? What's the path if that changes and we suddenly don't like the new world? Are we comfortable being on HashiCorp tools and Confluent and whatever IBM does for AI, all from the same vendor? If you're not on Confluent, but you've been evaluating it, this changes the comparisons with MSK and self-managed Kafka a little bit. On the plus side, IBM has deep enterprise relationships and is very good at, let's say, long sales cycles. That might mean better integration with big company identity, governance, on prem stories, all of that. On the minus side, every time a company like this gets acquired, there's a non zero risk of focus shifting to bundle this into everything instead of make the core service amazing. If you're on MSK or self managed Kafka right now, I don't think this is an immediate you chose wrong moment, but it is a reminder to check your own vendor concentration. If the same company controls your infra control plane, your secret management, and your streaming backbone, you should at least have some kind of exit plan on paper. Not because you're going to use it tomorrow, but because you really don't want to start thinking about migrations the week after a pricing email lands. So the homework here is simple. If you use Confluent anywhere, write down what Plan B looks like. If you don't, decide whether this acquisition makes you more or less likely to adopt it in the next couple of years. And maybe keep an eye on what IBM does next in the infra AI space, because they're clearly not done shopping. All right, let's talk about something more urgent, React2Shell. React2Shell is one of those vulns where the score is 10 out of 10, and unfortunately, that's not an exaggeration. Very short version, React server components use a protocol called Flight to talk between client and server. There's a bug that lets an attacker send a malicious payload through that protocol and chain it into a remote code execution on the server side. So this is not someone can mess up your CSS. This is someone can run arbitrary code on whatever is hosting your React server components. Why should you care if you're just the platform person? Because a lot of modern front-end stacks are now front-end plus server-side piece deployed as containers into your Kubernetes clusters or your app platform. Those pods are part of your blast radius. If they get popped, the attacker is one kubectl away from the rest of the cluster or one IMDS hop away from credentials. Patches are out in the ecosystem. Next.js and others have shipped fixed versions. React has guidance, the usual wave of advisories. But there is real exploit traffic in the wild already, and cloud providers and security vendors are seeing this used to drop loaders and pivot deeper. So, what do you actually do as a platform SRE person? First, assess inventory. Figure out which services in your world are using React 19, React Server Components, Next.js with RSC, that kind of thing. If you don't know, this is a good week to ask app teams some annoying questions. Second, patch tracking. Make sure those services are on the patched versions of their framework. This is one of those we're doing an emergency patch even if the sprint board doesn't like it weeks. Third, guardrails. If you have a WAF, check whether your provider has shipped React2Shell rules and turn them on in at least monitoring mode, ideally block mode for the exposed endpoints. Same thing for IDS, IPS, or runtime security tools. Fourth, egress and privileges. Double check the egress posture of those front end services. If an attacker does get code exec, how easy is it for them to phone home, hit IMDS, pull other secrets, or talk to internal services that they really shouldn't? You don't need to become a React expert. You just need to treat this like what it is, a serious server-side RCE that just happens to be riding in on a front-end stack. All right, let's move from everything is on fire to how one of the big kids is evolving their database story. Netflix published a case study about consolidating a big chunk of their relational database fleet onto Amazon Aurora Postgres. The headline numbers they quote are up to 75% better performance and almost 30% cost savings for some workloads. Now, you should always be a little skeptical of round numbers, but the pattern is pretty familiar. They had a bunch of self-managed Postgres clusters scattered around. Each one had its own tuning, its own backup setup, its own failover behavior, its own on-call expectations. Over time, that turns into a huge operational tax. Moving to Aurora gave them a few things: managed failover and backups instead of writing and maintaining that themselves, a more uniform story for observability and performance tuning, the ability to simplify sizing and autoscaling in a more consistent way. From our side of the fence, the interesting question is not should we be Netflix, it's where do we get outsized value from letting the cloud provider manage more of the boring stuff. If you have a handful of big, weird Postgres clusters with very tight latency requirements, very custom extensions, or unusual replication topologies, self-managed might still be the right call. But if you have 30 or 50 little to medium Postgres instances that all need roughly the same reliability story, and none of them are super special snowflakes, something Aurora-like starts to look pretty attractive. The trade-offs are similar to what we just talked about with Confluent. You're consolidating onto one managed platform. You get reliability and lower ops overhead at the cost of more vendor lock-in. There's no free lunch there. The takeaway I'd want people to get from the Netflix piece is not, oh cool, Aurora is magic. It's you should occasionally step back and ask if the way you're running your databases is still the right shape for the scale you're at now. If you built a fleet of hand-tuned clusters back when you had 5 apps, that might not be the right model now that you've got 100. All right, let's knock out a quick lightning round. First up, OpenTofu 1.11. OpenTofu keeps moving quickly, and 1.11 brings some nice language features. There's an enabled meta argument you can use on resources and modules to conditionally include things without the old count equals zero hacks. And there's support for ephemeral values, so you're not forced to jam every intermediate into state forever. I'm not going to go line by line through the changelog, but if you've been Terraform curious about OpenTofu, this is a good excuse to try it out on a small non-critical stack and see how painful or painless the migration is. At minimum, be aware of it so you're not surprised when someone on your team says, hey, can we standardize on this instead? Next, a Terraform tips post from Rose Security that I liked. It's one of those small things that add up articles. Stuff like using one instead of bracket zero bracket when you really expect a single value, shaping variables as objects with optional attributes so you're not passing around random maps, that kind of stuff. This is the kind of post I'd quietly drop into your Terraform channel or internal docs, and then steal ideas from the next time you touch a core module. You don't have to refactor everything at once, but tightening up the patterns over time does pay off. Third lightning item, Ghosty going nonprofit. Ghosty is a GPU accelerated terminal emulator that's gotten really popular. And Mitch Hashimoto announced that it is now under a nonprofit umbrella instead of being a commercial product in waiting. I'm not going to pretend that this is a pure DevOps story, but I do think it's interesting to see a dev tool with this much traction explicitly choose a nonprofit ownership model. After watching things like Terraform's license change and all the drama around open core tools, it's kind of refreshing to have a core tool say, nope, this is going to be community governed. And last lightning item, spec-driven dev with AI. GitHub released SpecKit, and there's also a project called OpenSpec from Fission. Both are playing in the same space. Instead of just prompting your AI assistant with, hey, write some code, you start with a structured spec that says what you're building and how you'll know it's correct. And then you let AI generate plans, code, and test anchored to that spec. From a platform perspective, I think this is the only sane way AI is going to touch infrastructure at scale. Imagine a spec for new service on our platform, or standard Kubernetes app, or new CI pipeline, and then the assistant uses that spec to generate Terraform, Helm, and policy that fits your patterns. We're not there yet in most shops, but watch this space. It's way better than let the bot randomly edit production YAML. All right, let's talk about incidents and brains for a minute. For the human bit this week, I want to pull from an article called Your Brain on Incidents. It's about what major incidents actually do to people, not just systems. If you've ever been on a multi-hour call where everything is breaking and the pager will not shut up, you already know the feeling. Tunnel vision, bad decisions, snapping at teammates, that sort of thing. The article talks about cognitive load and stress responses in a pretty approachable way. When you're in an incident, your brain is juggling a ton of context: logs, dashboards, Slack, tickets, leadership asking for updates. On top of that, if you don't feel safe saying, I don't know, or we need to slow down, your brain goes into pure defensive mode. That's where blamey cultures make everything worse. If every mistake gets dissected in the most painful way possible, people will hide information during the incident and the postmortem. You lose exactly the insight you need to get better next time. So what do you do with that as an SRE or platform lead? 1. Be explicit about expectations during big incidents. It's okay to say we're going to pick one hypothesis at a time and we're allowed to be wrong. It's okay to say someone needs to be the scribe and someone needs to tell leadership to wait 5 minutes for an update. 2. Design your incident process so it takes some load off of the humans. That could be better runbooks, better dashboards, or just a clear template for how to structure a Slack channel during an event. 3. In the review, focus more on how people reasoned under pressure and less on who typoed the command. You want people to feel safe saying, I was fried and I misread the graph, because that's how you find the systemic fixes. And maybe most importantly, Remember that people have a limited number of massive incident nights in them before they burn out. That's not a moral failing, that's just biology. All right, that's it for this episode of Ship It Weekly. We talked about IBM buying Confluent and what that means for streaming and vendor risk, React2Shell, and why a React vuln absolutely still belongs on your platform radar, and Netflix moved to Aurora Postgres as an example of rethinking your database fleet. In the lightning round, we hit OpenTofu 1.11, some Terraform cleanup ideas, Ghosty going nonprofit, and spec-driven development with AI instead of free-form prompt chaos. And we closed with your brain on incidents, and a reminder that your systems aren't the only thing taking damage during a bad outage. I'm Brian. This is Ship It Weekly by Tellers Tech. Thanks for bearing with the cold voice version of me. I'll drop the links for this episode in the show notes, and I'll see you in the next one.